Hey, hi everyone. I hope you all are doing good. So, in my today's session, I'm going to start with structural design patterns. So, in structural design patterns, I will start with the first pattern being the adapter design pattern. So, what is an adapter design pattern? An adapter allows two incompatible interfaces to work together. This is the real world definition for an adapter. I think we would have seen a lot of such adapters. Okay, interfaces may be incompatible, but the inner functionality suit the need. Okay, in most of the cases we would be having some legacy devices, legacy hardware, or a legacy software component whose functionality will satisfy our needs. Only thing, because of incompatible interfaces we are not able to integrate them. Okay, so the adapter pattern converts the interfaces of a class into another interface the client basically expects. Adapter lets classes work together that couldn't be otherwise because of incompatible interfaces. The adapter design pattern is one of the 23 well-known gang of four design patterns that describe how to solve recurring design problems to design flexible and reusable object-oriented software. That is, objects that are easier to implement, change, test, and reuse. Okay, so let's see. The adapter design pattern solves what problem over here? So how can a class be reused that does not have an interface that a client requires? So there is an existing legacy class which has the functionality which satisfies our need, but the interface is not compatible with the client which he is expecting. How can classes that have incompatible interfaces work together? How can an alternative interface be provided for a class? Okay. So often an already existing class can't be reused only because its interface doesn't conform to the interface that client is expecting. The adapter design pattern describes how to solve such problems. Define a separate adapter class that converts the interface of a class into another interface that client require. Okay, the incompatible interface of a class, which is also called as adaptee basically, into another interface target that client basically expects. Okay, work through an adapter to work with classes that do not have the required interface. Okay, it all about providing an interface and working through that interface also. Okay, these are the two steps. The key idea in this pattern is to work through a separate adapter that adapts the interface of an already existing class without changing it. Guys, mark this word. Okay, the key idea over here is to work through a separate adapter or adapter class that adopts the interface of an already existing class, okay, without changing it. Okay, this way we are not violating the solid principle. Okay, the single responsibility principle basically. Client don't know whether they work with a target class directly or through an adapter with a class that does not have the target interface. Okay, so the adapter pattern can be implemented in two ways, so which is in object adapter and one is a class adapter. I'm showing the UMLs over here. This is a very simplest approach of implementing adapter pattern is using the object wrapper basically or object adapter. So what happens here? You have an interface, okay? The target interface which has an operation, that's what you want to invoke, and the a concrete class implements that target interface and also provides implementation for that operation. And that operation basically what it does, it will compose, it will basically contain that object of adaptee within itself. Okay, so in this particular scenario the adapter class will contain the adaptee as a class member, or the existing class component which will satisfy our need is basically put as a class member, and it is called as adaptee. And what we do basically, whenever this adapters operation is called, right, we simply call that adaptees method which we want to perform, that's adaptee dot specific operation. Very simple to implement. Another way is the class adapter, guys. So here there is a little more clarified way. Basically we apply this process or this pattern, I can say. So what happens over here is we have a client, we have a target interface, okay, which will specify a operation, and a adapter class basically implements that interface, the target interface, and it provides the implementation for that operation. Now this particular adapter class over here, guys, it will basically contain the adaptee as a class member. Okay, and what it does whenever this operation is called, okay, so it will simply calls that specific operation. Okay, or it it is possible that there are two ways again here. It can basically inherit from that adaptive class itself. Okay, if it can inherit from that adaptive class itself, and it can basically invoke that specific operation. Okay, so these are the two approaches I have explained over here. So what are the advantages? It helps achieve reusability and flexibility. Okay, because uh, in our software industry we basically have a lot of code which is already written, which is reusable. Okay, so instead of creating something new or reinventing the wheel, it is always better to reuse such functionalities. So that's what they say, helps to achieve reusability and the flexibility basically. So flexibility in such a way that you are basically making two incompatible interfaces to work together. The client class is not complicated by having to use a different interface, and can use polymorphism to swap between different implementation of adapters. Okay, disadvantages: all requests are forwarded, so there is a slight increase in the overhead. Yes, because your target is not basically performing that processing. It will be forwarded to your adaptees or the existing classes or the functionalities basically, or software components. Sometimes many adaptations are required along an adapter chain to reach the type which is required. So especially in case of this class adapter, right? Sometimes you have to provide a lot of implementation for your adapter. For example, performing some operation. If a process contains n number of operations, okay, and for each and every step in that operation or workflow, you have to provide an adapter so that you can get the required desired functionality or the data, and then finally you will reach to the result you are expecting. So there will be a lot of adapter classes or the subclasses which are basically providing piece of functionality which we are expecting in our final product. Okay, so that's all about the theory involved with this pattern. So let me explain with an example. So that's my example. So I have a system, basically a text formatting library you can call. I have written my own library to perform all text formatting operations, and I have a base contract, or you can call a public contract, which called iText formatter. Okay, and it has one operation which is called format text, and when you supply some text as an input, it performs some formatting operation. Okay, this is a very generic way. Okay, it's a contract I'm specifying with this interface, iText formatter. Okay, now in my application, that is my system. Okay, I have a piece of functionality which I have written, which is called new line formatter. So basically, whenever I give a, okay, a paragraph of text, okay, or a text block basically, okay, which contains dot operator. Okay, just for a demonstration of this particular pattern. Okay, if it contains statements ending with dots. Okay, so my new line formatter, what it does, it's very simple. Okay, my new line formatter implements my contract or the interface iText formatter, and it provides the implementation to perform new line formatting. Look at the abstraction, iText formatter. Okay, you don't know what kind of formatting you are going to do. Okay, now I am giving a concrete implementation which is called new line formatter, which performs new line formatting of a text. Okay, so what it does, very simple operation, format text, which implements the format text method coming from iText formatter, and simply applies text dot replace dot by the new line. Okay, so if I give a paragraph or basically batch of text containing dots, it will simply give me a new line separated, okay, statements. Okay, a very simple or a trivial example or a piece of functionality which I have, but I came up with a requirement basically. Okay, so I came up with a need where I have to perform basically CSV formatting. Okay, for example, if my client gives me a bulk of text or a block of text, and if it contains a lot of dots in within it, then what I have to do is basically I have to replace all those dots by commas so that it can be CSV compatible, or it can be used in a CSV file. Okay, so the problem with this implementation is that this is not my component. Okay, this is coming from a vendor. So what the vendor has provided, he has a contract, same way the way how we have a contract, he also have a contract called ICSV formatter. Okay, but he provides an interface called format CSV text. Look at the name, format CSV text. It's not format text, it's format CSV text. Okay, so this code is not at all accessible to me. I can't go there and make changes in order to make it work with my system. Okay, so this is coming into a DLL. That's it. I don't have any source code, and he has provided a concrete implementation which implements ICSV formatter and replaces dots by comma and returns the text. Okay, so this is coming from a vendor or a third party library creator basically. Okay, now I have to write my application software in such a way that I should be able to make use of this third party library to perform CSV formatting in my application. So how will I write the adapter implementation? Okay, so my adapter implementation will look something like this. Okay, so public class CSV adapter implementation, which basically implements iText formatter. Okay, look at the base contract which I have in my application, iText formatter. Okay, so this is a very generic contract which says that format text. You can do new line formatting, you do CSV formatting, okay, you do XML formatting. It's up to you. Okay, I'm giving a base contract. Okay, so what I'm going to do is my CSV adapter implementation class, what I do, I will simply implement the interface iText formatter. Okay, and then inside this my adapter class, I will have my ICSV formatter, which is given by my third party library creator, basically. Okay, or the vendor. So what I am going to do is I will make it as a class member here. This particular class, that is ICSV formatter, okay, functionality. Then I will provide implementation for my format text, which is coming from iText formatter. Okay, and here what I do, I will format the text to CSV format using my third party library class, that is ICSV, sorry, interface called ICSV formatter, and I simply call the method format CSV text on that. Okay, so I will use that instance CSV formatter and call the format CSV text, and I will pass the incoming or the input text. So it will automatically, now it's a complete responsibility of this third party library class, which is CSV formatter. It will receive my value and apply that CSV operation, and it will return me the CSV text. Okay, that's it, very simple. Okay, so adapter is ready. Okay, now let's go through the client application. My main program is my client application. Okay, so what I'm doing, first thing, I have a string, test string, okay, which has statements terminating with dot, but they are on single line. So first I will apply my new line formatter, iText formatter, new line formatter equal to new line formatter. And when I call new line formatter dot format text, it will basically return me this single line into three lines, that is formatting line 1, line 2, and line 3. Okay, then comes the then comes the functionality of applying CSV formatting. Okay, now what I will do is, okay, first, I'm going to create an instance of the CSV formatter class, which is coming from the vendor. So I CSV formatter equal to new CSV formatter. And then what I will do, I will instantiate my adapter class, okay, because my adapter implements iText formatter. So what I do, iText formatter CSV adapter equal to new CSV adapter, and I will pass my vendor class instance, that is CSV formatter, which is coming from his library. Okay, now what I do, CSV for adapter dot format text. So what it will do basically, okay, if you come here, this is my contract format text, and my adapter is also implementing iText formatter. So when I call format text, the runtime polymorphism will apply, and it will basically call this method on CSV adapter implementation, and internally it will call CSV formatters format CSV text. So that should give me this particular line separated by commas. So let's run this program and verify. So that's it. We got the results. So if you see, first I applied a new line formatting. So new line formatter is my application class. It's the class which I had written. So it performed the formatting for me. It put all the dot separated one liner statement or the text into new line formatting by removing the dot by slash n, that is the new lines. Okay, then I applied the CSV formatting. See the beauty, it basically applied the CSV formatting also. It replaced the dots by commas, and it gave me a comma separated text. Okay, so that's all about the adapter design pattern. Okay, So it will make your classes or incompatible interfaces to work together by making use of this particular pattern. Okay, it's very simple and easy to understand. So I hope this session will be helpful for you people, and wherever possible, and if you encounter these scenarios where you want to reuse an existing class library, okay, and the interfaces are incompatible with your client, then definitely apply this pattern and make use of it. Thank you for listening and have a nice day.